Hey, good morning, squad. Mr. Hurt here. Um, yeah, hopefully you're enjoying your asyncratic day. Hopefully you didn't have to get up too early for all this today. So, today, here on our video, we're going to talk about some practice materials to get us ready for Friday's test. Um, so it's in your workbook or the PDF that you've been using the whole time. Additionally, you definitely want to put the work in today because no matter what tomorrow holds, whether we're here face to face or whether we're asyncratic again, or hey, I don't know, maybe it'll just be a full blown snow day. Either way, Friday the test is on like Donkey Kong. All right, so we're going to do a few practice problems together, nothing crazy, and then I'll kick the key to these pages as well. All right, so without further ado, let's do this thing. Sorry about putting that in my folder spam. If you're saying, oh man, where are you at in the booklet? Last night we had practice 7.5 as our homework. Check, check. I did kick the key to that yesterday, so hopefully you've been crushing that. If you flip that page, just so you know sort of where we're at, there's some practice problems. 1 through 4 there are all either scales. Don't forget how to do scales, so we'll do that one together. Some proportional stuff. There's some practice proofs. And then if you flip the page, there's things like angle for similarity, side for similarity, side for similarity. Okay, so yeah, that's a whole bunch of practice. Last but not least, and then we're going to dive in. For those of you that are concerned about the right triangle problems, reteaching 7.4, there's a whole bunch of right triangle problems, and I'll kick the keys to those as well. All right, so without further ado, let's just do a few review problems to make sure we're good to go, and I'll try to keep the video short and sweet. Okay, so ratio problems. Hey, it's been more than a minute since we've done a ratio problem, so let's glance in real quick. A tower is 1,275 feet high. The model of the tower is 36 inches. What is the ratio of height of the model to height of the actual tower? So I think because 36 inches equates so easily to 3 feet, I think that's what I'm going to change. Why? Because we want to have our units be the same. So 3 feet compared to 1,275 feet. It's crucial that these are the same units, and then we reduce. Okay, well, they both have a 3 in common. You're saying, no way, Mr. Hurt. I'm saying, yes way, fam. Sorry about the stand bouncing. 1 to 425. We just reduced both of them by 3. Okay? We did some stuff like that. Let's see down here. Number 4, explain why the triangles are similar. Well, it's angle similarity. You might say, why, Mr. Hurt? You have multiple reasons. You could say because they share that angle right there, and then they also have corresponding angles here, but they also have corresponding angles there. So you have all the angles, so it's definitely angle for similarity. Now, we want to be careful about this. Let's look at our top triangle there. We have x and x minus 2 are the left and right side, respectively. Equals, here's the thing though, squad, when we look at the entire left side, it's x and x plus 5. Well, the entire left side is 2x plus 5. You feel me? Similarly, the entire right side is x minus 2 plus x plus 1, pardon me. So that's 2x minus 1. Once it's set up, we cross multiply and we go. If you're saying, but old man, quadratics, don't worry, it's all going to cancel out. We have 2x squared minus x when I distribute there. Here we have, and I'm just foiling, and in the interest of time, you know how to foil, so I'm going a little quicker. I hope you don't mind. Here we have 2x squared plus x minus 10. You might say, but, mister, look. Here's the thing. We're going to subtract 2x squared from both sides. They're going to cancel. Check. We're also going to subtract x from both sides. Check. We get negative 2x equals negative 10. Therefore, you don't need to be a math teacher. X must be 5. Okay? So far, so good. Let's do a practice proof, super quick. Once again, super quick. Hey, you always want to start with what you're given. So I'm starting here on number 2. Angle D is congruent to angle G. Thank you, given. I always throw that in our picture, okay? Also, we have vertical angles there. Angle DEC is congruent to angle FEG because of the vertical angle theorem. Check. Therefore, we have 2 different angles. Check, check. Therefore, triangle DEC must be similar to GEF. Thank you, angle for similarity. Okay? I'm telling you right now, there's going to be a proof on the test. You've been warned. Yeah, and I'm watching the time. I know the video is at 6 minutes. I'll go as fast as I can. Hey, speaking of the video, feel free to pause if I'm going too fast and scroll back so that you can catch back up. Flipping the page, if you're saying, where you at, old man? Similar triangle practice. There's no wrong answer here. I'm just going to do number 14. Remember, side splitter as well as the angle bisector, it's all proportional. So I'm going to go 6 over 3 equals question mark. I'm using an x over 2. You don't need to be a math teacher. You realize very quickly x is 4. Okay? You're saying, but bro, what if it's an angle? Gotcha. Okay? I'm going to go 12 over x equals 16 over 8. Cross multiply and go. You don't need to be a math teacher. X is 6. Okay? Last but not least, because I know the video is longer than I anticipated, my bad, I'm going to flip all the way back to reteaching 4. For those of you that need practice problems when it comes to these types of problems, you know, set up and go, I'm going to redraw them, I'm going to set up, and then I'm going to trust that you can do the proportions. So like right here, we always have a small, a medium, and a large triangle. Look, I know my pictures aren't perfect, but they're all orientated the same way. The base is always the short side, the height is always the medium, the hypotenuse is always the long. So then we just label and go. So my small is 6, 3.6, and a height of x. Okay, check. My medium, so I'll turn that one upright, is x for a base, y for a hypotenuse, and 6.4 for a height. And then my large, well, that has a base of 6, a height of y, and you add those two together, sure enough, and a hypotenuse of 10. Then just looking, I say, all right, what relationships do I have? X over 3.6 is 6.4 over x. Oh, nice. Okay. Another relationship, 6.4 over y is y over 10. Okay. So I know the redrawing is hard, but I just talked you through the setup as well. All right. Try to keep it under 8.5 minutes. Have a good day. Remember, test Friday. Good luck, squad.